In lesson 4-2, we're going to be finding greatest common factors of two or more numbers. To find greatest common factors, we'll be using a method called the L method. Using the L method, we're going to be finding the greatest common factors, or the GCF. To find greatest common factors of 28 and 42, we can use the L method by writing the numbers 28 and 42 and drawing an upside down division sign. What we need to find is a number, a factor that can go into both 28 and 42. Since both of these two numbers are even, 2 can go into both of these numbers. 2 goes into 28 14 times, and 2 goes into 42 21 times. Neither 14 nor 21 are prime numbers, so we will do it again. Now I'm going to try to find a bigger number that can go into both 14 and 21. I know that 7 goes into both 14 and 21. 7 goes into 14 2 times. 7 goes into 21 3 times. Since both 2 and 3 are prime numbers, I am finished. To find the greatest common factor, I will look at the two numbers on the left-hand side of my L bracket. I need to multiply those two factors, and 2 times 7 is 14. So, the greatest common factor of 28 and 42 is 14. To find the greatest common factor of 18 and 45, again, I start off by writing 18 and 45, and I begin my L method. Thinking of a number that goes into both 18 and 45, if I check my divisibility rules of 9, 1 plus 8 is 9, 4 plus 5 is 9. Since both numbers are divisible by 9, I'm going to go ahead and divide by 9. 9 goes into 18 2 times. 9 goes into 45 5 times. Since both of these numbers are prime, I am done, and the greatest common factor of 18 and 45 is on the left-hand side of the L method, and I only have one number, so that number is 9. To find the greatest common factor of more than two numbers, I'll do the same thing. 21, 42, and 63. The L method works because I am finding common factors on the left-hand side, and I'll use those common factors to multiply together to find the greatest common factor. So what number can go into 21, 42, and 63? Well, if I check my divisibility rules of 3, 1 plus 2 is 3, 4 plus 2 is 6, which is divisible by 3, and 6 plus 3 is 9, which is also divisible by 3. So I'll go ahead and divide all three of these numbers by 3. 3 goes into 21 7 times. 3 goes into 42 14 times. And 3 goes into 63 21 times. 7 is a prime number, but I noticed that 14 and 21 are composite numbers with the prime 7 used as a factor. So I can use the factor of 7 to divide into each of these three numbers. 7 goes into 7 once, 7 goes into 14 twice, and 7 goes into 21 3 times. Since all three numbers are prime at the bottom, and I can't go any further, then that means the numbers on the left-hand side of my L method, I need to multiply them together to find my greatest common factor. 3 times 7 is 21. Example number 4. Again, we're going to find the greatest common factor of three numbers. 24, 48, and 60. I'll start my L method. When I look at these numbers, I want to try to find one of the largest numbers that I can to go into these numbers. I notice that they are all even. 4 is even, 8 is even, and I know that 0 is divisible by 2. So I could start with 2, but I'm going to try to find a number that's larger than 2 that can go into all three. Thinking of my multiplication facts, I know that 6 can go into 24 4 times. 6 can go into 48 8 times. And 6 can go into 60 10 times. Since these three numbers are not prime and they're all even numbers, I know that I can go further. And this time I'll go ahead and divide by 2. 2 goes into 4 2 times. 2 goes into 8 4 times. And 2 goes into 10 5 times. Since 2 and 5 are prime numbers, and I don't have a number that can go into all three, I know that I'm finished, but I need to look at the left-hand side of the L method, and I notice I have two factors, so I need to multiply them together to get the greatest common factor of 24, 48, and 60. And 6 times 2 is 12. So 12 is the greatest common factor. Example number 5. I'm going to use the same method that I did before. I have 10j times k and also 15 times k. I use the same process here in finding common factors. Okay, I have the number 10 and I have the number 15. A common factor for both of those is 5. 5 goes into 10 twice, and 5 goes into 15 3 times. Okay, I do need to bring my j and k down because I did not factor those out of my problem. And in this problem, I only have k to bring down. 2 and 3 are both prime numbers, but I do notice that I have a k that is common to both answers here. So I can go one step further and I can factor out a k. If I factor a k out, that's going to leave me with 2j. And we'll factor a k out. 3k divided by k is 3. So now 2 and 3 are both prime, and I only have one j. There's no j's with the 3, so there's nothing else to factor out. So I need to look at the left-hand side of my L method. I need to multiply those two factors. So the greatest common factor of 10 times j times k and 15 times k is 5 times k. Example number 6. Alice is making candy baskets using chocolate hearts and lollipops. She is tying each piece of candy with either a red piece of string or a green piece of string. She has 64 inches of red string and 56 inches of green string. She wants to cut the pieces of string in equal length and use all of the string she has. What is the length of the longest piece of string that can be cut? So we need to find the greatest common factor of 56 and 64. So I'm going to start by writing those two numbers right here, 56 and 64. And I'm going to start with my L method. What is a number that goes into both 56 and 64? I know that 8 goes into both. 8 goes into 56 7 times. And 8 goes into 64 8 times. 8 is not a prime number, but 7 cannot go into 8, so I know that I'm done. So my greatest common factor of 56 and 64 is 8. So the longest piece of string that can be cut is 8 inches. My greatest common factor is found on the left-hand side of the L method. There is a second question. How many pieces of string can be cut from each color? So if I'm going to cut 8-inch long pieces, if I'm starting with 56 inches, I just look at the bottom of the L method, and I will be able to cut 7 pieces that are 8 inches long, because 7 times 8 is 56. So I need to look up here and find out what color that is. And we had 56 inches of green string. So I'll be able to have 7 green. And I know that since I have 64 inches of red string, I know that I can make 8 pieces that are 8 inches long, because 8 times 8 is 64. So I will have 8 red